Hi, my name's Eleanor Dearlove. I'm an IPM consultant at ADAS in the UK, and I'm going to be demonstrating today how to use the IPM Decisions Platform. The IPM Decisions project is funded under the European Commission's Horizon 2020 programme, and the main objective is the development of the online platform hosting decision support systems related to the integrated management of crop pests. Here I'm going to demonstrate the platform in action, which is now live and accessible to all. But before we jump in, just to clarify, where I'm referring to pests, I'm talking about any weeds, pathogens or invertebrates that may cause injury to crops. Decision support systems can cover anything from forecasts to thresholds, but ultimately indicate the risk associated with crop-pest interactions at any given point in the season. The platform is an online marketplace for accessing IPM decision support systems, which will also be referred to as DSS or DSSs, and associated models, resources such as weather data. The platform consists of 4 dashboards targeting different aspects of decision support systems. The first 2 are the Use and Compare DSS dashboards. The Use DSS dashboard is the main area for seeing current pest risks. Then we have the Comparison dashboard, which is where different systems can be compared. Or the same system can be compared at different locations or with different details, for example, with or without spray applications. First thing we need to do is register an account. This is the home page of the platform. Here, users are directed to summary information about the platform, news and events, and other useful links. There are specific summaries for how farmers and advisors, researchers or developers can use the platform and how to get the best out of the resources available. To register an account or access an existing account, the user must select the option at the top of the page. The platform is currently available in several languages, and additional languages will be added as the platform develops. New decision support systems are translated as part of their integration process. There is a simple registration process to set up your account, but users do need to accept our terms and conditions before using the platform, which is largely to protect users and developers from the misuse of the systems hosted here. Once these are accepted, the user gets instant access to the platform and the account needs to be verified within 48 hours. An email will be sent to the address provided. Once we've registered, we are now able to use the IPM Decisions platform. Once a farm has been set up, users will always log straight into the DSS use dashboard, given an immediate summary of current pest risks. In this case, we've set up a digital demonstration farm near Cambridge in the UK, and I've added a DSS for codling moth, a pest of apple trees. As we can see, the DSS box for this pest in apples is green, indicating that this system is active and the model is forecasting a low risk for this week. If the box was grey, this would indicate that the system was inactive, i.e. this pest is not expected to be present as a risk to crops at this time, and the model is not running. Alternatively, the risk may be indicated as yellow, which is medium risk, or red as a high risk. As well as the colour risk status, there is also an alert on the model, the green exclamation mark. This indicates that there is additional information about the model that should be considered. If we hover over the DSS box, we can also get some further information on what the model is doing. In this case, estimating the risk of first flight of codling moth, which is associated with the start of egg laying in apple orchards. We can find out more about the model by clicking on the eye symbol. This gives a little more detail about the warning status and other background information. But let's look a little bit closer at the model outputs. If we click on the model, it opens up a detailed screen. Here, we can see that the risk of migration is low all week. The chart is shown for all systems. In the middle, the users can request a chart that illustrates the model. In this case, this shows the predicted cumulative proportion of codling moth expected to be captured at this location this week. This is based on 3 generations of moths per year. We click on the Show Data Legends to reveal titles. Here, we can see that the green line is nearly at 100%, i.e. the first migration is complete, and the red line, the second migration, is over 70%, by which point the system assumes that the user has already reviewed the potential site-specific measures and actions required. There is no third migration line, indicating that this has not yet begun, and it's unlikely at this location this year, so the model becomes inactive after October. This is because third generations of codling moth are not expected at locations across Northern Europe. So location is an important aspect to improve the accuracy of the models. We can set up our location through the Farm Management tab on the left, and this is where you will be taken when you initially register on the platform. Now I will show you how to set up a farm location on the IPM Decisions platform. To create a farm, you name it and select the location from the map. There will be a delay between setting the farm up and the weather being linked to that site. This is simply because there is a large amount of weather data behind each location, and these are only drawn into the platform once a new location request is made. Once the farm is named and the location selected, it can be saved and the DSS can be added. To do this, you go back to the Farm Management tab. Here, you can edit, copy, or delete a farm. We'll select the Edit icon. At this point, we can either edit the location or add DSS. Let's add a DSS model. DSSs are added by relevant crop, so you can select the crops that you're interested in and then the associated DSS. You can add multiple crops by holding down your control button and selecting all crops by selecting Control and A. For now, I want to add DSS for an onion crop, which is part of the allium species crop group. The DSS available for allium species is for cutworm. Now, this is mainly a problem very early in the season rather than in October when this system is being demonstrated, but it will serve for illustrative purposes for now. I can see that this model is appropriate for allium crops, including onions, and for cutworm, and is relevant for use in several regions in Europe. I can find a bit more detail through the eye icon. This presents a description of the model, including what it's for, briefly how it works, who developed it and where, and any assumptions that should be considered. Once we are happy to use the model, we can select it and it's added to the Use dashboard. Now you can see the cutworm model has been added alongside the codling moth DSS that we looked at earlier, and it's reporting a high risk alert. Let's click on that and take a closer look. This model is calculating the number of batches of first to third instar larvae that could be present in the crop. A batch is a generation of larvae from the last egg laying, and once the batch reaches fourth instar, it moves into the crop tissue and surrounding soil, and it can no longer be treated. When 4 or more batches are predicted to reach fourth instar, a high risk is reported. Here we can see that the system is forecasting 12 batches of first to third instar larvae, which could be active in the crop, and the guidance suggests in-crop monitoring to assess the actual risk. Let's say the farmer on this occasion is intending to apply a treatment tomorrow. We can add that into the system by editing the parameters. I will add a spray application for tomorrow, and let's see what that does to the system. Back to the dashboard, and the risk is still high, because of course spraying tomorrow hasn't reduced today's risk. But if we look in more detail, now the model assumes that the spray application has effectively removed all larvae and has reset the model to 0. We can continue to track the model and ensure that sprays are timed to be most effective and minimise the number of applications. A further function of the model is to enable comparison of models, treatments, or locations. Now I will demonstrate how to use the DSS comparison function in the IPM Decisions Platform. Let's say we're an advisor supporting 2 neighbouring farms and we want to compare risk. We add our second farm. We add the DSS we want to use on that farm, and in this case, the same system as before for cutworm on onions. Now we can see the risk on both farms in the use dashboard. Again, the risk is high as by default it assumes no spray applications have been made. Let's add one in now. So here I will report that a spray was applied in mid-August. Save and update. And now the risk is medium. So the number of batches reaching 4th instar isn't yet at the threshold of 4, but it could reach that soon. You can add as many locations and DSSs as you would like, but it gets a little difficult to compare what's going on. So we've developed a comparison dashboard. Once your farm location is selected, click Save and you'll go back to farm management. In the comparison dashboard, we can select up to 5 different models or locations to compare. I will pick the cutworm model at each location. And we can see them contrasted against each other, with the medium increasing risk at farm 2 and the high changing to low risk at my digital demo farm. As the number of DSSs on the platform grows, this tool will enable users across Europe to compare systems developed in different regions and make decisions about which are most applicable to them. The third dashboard enables users to edit core parameters within these models, adapting them to local pest phenologies in order to better support local decision making. The platform has been designed to integrate a range of different DSSs from across Europe in a simple and consistent way. If you'd like more information, please visit the IPM Decisions project website or email contact@ipmdecisions.net.